Mars holds many mysteries and stark contrasts. Vast barren rocky expanses lie beside towering volcanoes. Its surface reveals numerous ancient collisions with giant canyons and craters. A thin atmosphere filled with tiny rusty sand particles is constantly swept by strong winds in relentless sandstorms. This is Mars, a mysterious and forbidding planet. Let's explore it. Hello and welcome to Z. Please don't forget to subscribe and hit the bell icon. Mars is about 1.5 times farther from the Sun than Earth. Unlike our planet, its radius is half as large. Its mass is roughly 10.7% of Earth's, and surface gravity is nearly 3 times less. Temperatures vary from -153 degrees Celsius at the poles to 35 degrees Celsius at the equator. Mars's surface area is about the same as all Earth's continents combined. Its terrain is diverse, with some features resembling Earth's and others unique. Mars's surface is closely monitored from orbit by 8 automatic space probes. Data shows a vast light spot in the western hemisphere, Olympus Mons, the largest volcano in the solar system. This is where our tour of the red planet begins. Olympus Mons stands 26 kilometers above the plains, about 2.5 times the height of Mount Everest. It's thought to be a shield volcano formed by multiple layers of solidified lava. With no tectonic plates, magma can erupt from the same spot for billions of years, creating vast rocky shields. Olympus Mons spans about 600 kilometers in diameter, covering over 300,000 square kilometers, comparable to a European country like Poland or Italy. A large depression with 6 calderas, or collapsed volcanic craters, lies at its center. This depression is about 85 kilometers in diameter and 3 kilometers deep. The atmospheric pressure at Olympus Mons peak is 50 times lower than at its base. Given Mars's thin atmosphere, conditions at the top resemble a vacuum, making it impossible for landing probes as the air is too thin for parachutes to slow down descending rovers. The average slope of Olympus Mons is gentle at 5%. But the volcano's edges end in steep cliffs up to 7 kilometers high. The formation of these enormous slopes is uncertain. Some theories suggest an ancient ocean, while others point to continuous sandstorms. Descending from Olympus Mons, we see numerous ridges and isolated mountains, some stretching up to 1,000 kilometers from the volcano's edge, possibly formed by erosion or ancient ice cap movements. Heading southeast, we reach the vast Tharsis region. This volcanic highland, made of solidified lava streams, covers about 1/4 of Mars's surface, an area comparable to Africa. Tharsis rises 10 kilometers above the plains and is estimated to be 3.7 billion years old. Many volcanoes here are nearly as tall as Olympus Mons. For example, Ascrius Mons stands 19 kilometers high, the second highest peak on Mars, with a summit caldera 110 kilometers in diameter and an overall diameter over 400 kilometers. A unique phenomenon occurs over Ascrius Mons annually. Sun-warmed slopes create small dust spirals that form a dense cloud, which can float up to 30 kilometers high and be scattered by winds. Tharsis features vertical pits, the largest about 150 meters in diameter and at least 178 meters deep, likely collapsed lava tubes. The region has dozens of overlapping shield volcanoes. Over billions of years, their eruptions released vast amounts of CO2 and water vapor, potentially creating an atmosphere 1.5 times denser than Earth's, suggesting Mars's past might have been more hospitable for life. But Mars's weak gravity couldn't retain this atmosphere, and it was eventually stripped away. East of the plateau lies Valles Marineris, a network of massive canyons stretching up to 500 kilometers. The canyon's width reaches 600 kilometers, and it's more than 11 kilometers deep. Images show stratified slopes, typical of deposits from a large body of water, hinting the canyons might have been submerged in the past. Valuable paleontological finds could be extracted from this region's rock deposits. The eastern valleys have a chaotic terrain, with labyrinths of small canyons, abysses, mountains, and plateaus. Further north, the terrain smooths into Christ Planitia, the resting place of the Sojourner Mars rover and Viking 1 probe, which sent the first color images of Mars in 1976. Widely accepted theories suggest Valles Marineris formed early in Mars's history, with erosion and geological processes deepening and widening the canyons. One theory links volcanic eruptions on Tharsis to the chasm system's formation, while another points to Utopia Planitia, a massive impact crater likely caused by an asteroid. In 1979, the Viking 2 lander sent back panoramic images of Utopia Planitia. In 2016, the Sharid radar on the MRO probe detected underground water ice deposits. In May 2021, the Chinese rover Zhurong landed there, covering over 1,000 meters of the Martian surface and sending back hundreds of images. However, it couldn't dig deep enough to reach the water layer, lying 1 to 10 meters underground. In the north, Utopia Planitia borders Vastitas Borealis, a huge lowland covering 40% of Mars's area. Moving southwest from Utopia Planitia's center, we reach Isidis Planitia. The western edge, Jezero Crater, has been under exploration by the Perseverance rover and Ingenuity helicopter since February 18, 2021. Jezero Crater, formed around 4 billion years ago from a massive collision, is thought to have held water during Mars's Hesperian period, about 3.5 billion years ago. Rock samples from the crater's bottom, recently collected by Perseverance, confirm continuous contact with liquid water. These samples will be brought to Earth for further analysis. Perseverance's mission is ongoing and expected to last 14 years, promising more discoveries. Despite extensive studies, Mars retains many mysteries. Some predictions suggest humans will soon set foot on Mars, marking a new era of exploration and discoveries. We will continue to bring you updates on these discoveries. NASA's relentless exploration of Mars has continuously yielded groundbreaking discoveries, and the latest photos from the Red Planet are no exception. These images, captured by the Mars rovers and orbiters, provide a vivid and intricate portrait of our neighboring planet, unveiling both its beauty and scientific mysteries. This essay delves into the latest findings, emphasizing the technological advancements that made these discoveries possible, the geological features observed, and the potential implications for the search for life on Mars. Technological advancements in Mars exploration. The ability to capture high-resolution images of Mars is a testament to the technological strides made by NASA over the decades. The Mars Reconnaissance Orbiter, MRO, with its high-resolution imaging science experiment, HiRISE, camera, and the Perseverance rover, equipped with its MASTCAM-Z cameras, represent the pinnacle of space photography and data collection. These instruments can capture minute details of the Martian surface, allowing scientists to analyze the planet's geology and climate with unprecedented precision. The Perseverance rover, which landed on Mars in February 2021, has been particularly instrumental in recent discoveries. Its suite of scientific instruments, including the SuperCam and Sherlock, not only capture images but also analyze the chemical composition of Martian rocks and soil. This multifaceted approach enables a deeper understanding of the planet's history and potential habitability. Geological features unveiled. The latest photos from Mars have revealed a plethora of geological features that shed light on the planet's past. One of the most striking images captured by Perseverance is of the Jezero Crater, an ancient lakebed that scientists believe once hosted liquid water. The rover's images show delta formations and sedimentary layers, indicating that water flowed and deposited minerals in this region billions of years ago. These findings are crucial, as they suggest that Mars had conditions favorable for life in its distant past. In addition to ancient lakebeds, the photos have uncovered diverse rock formations and mineral deposits. The presence of hydrated silica and carbonates, identified through spectroscopic analysis, points to prolonged interactions with water. These minerals can preserve biosignatures, making them prime targets for the search for ancient life. The intricate layering observed in some rocks also hints at cyclic environmental changes, offering insights into the planet's climatic history. Implications for the search for life. One of the most profound questions driving Mars exploration is whether life ever existed on the planet. The latest photos and subsequent analyses bring scientists closer to answering this question. The detection of organic molecules by Perseverance in the Jezero crater sediments is a tantalizing hint that the building blocks of life were present on Mars. While these molecules are not direct evidence of life, they significantly bolster the case for Mars as a once habitable environment. Moreover, the images have guided the selection of promising sites for sample collection. Perseverance is tasked with collecting and caching samples for a future mission that aims to return them to Earth. These samples, preserved in pristine conditions, could provide definitive evidence of past microbial life if such life ever existed on Mars. The meticulous documentation of the geological context through images ensures that scientists can interpret the samples accurately. NASA's latest photos from Mars offer a window into the planet's dynamic history and its potential to have harbored life. Through advanced imaging technologies and comprehensive scientific instruments, NASA has uncovered evidence of ancient water activity, diverse mineralogy, and organic molecules. These discoveries not only enhance our understanding of Mars, but also fuel the enduring quest to determine whether we are alone in the universe. As we await the return of Martian samples, the images continue to inspire awe and curiosity, driving humanity's exploration of the final frontier. Your support means a lot to us. Stay connected.